Standard 12 Chemistry Unit 14 Biomolecules Part 4. Last time we had discussed about subclasses of monosaccharides. Here we discuss about the glucose preparation and the structure of glucose is most important for 3 marks. Glucose is also known as dextrose and its molecular formula is C6H12O6. They are found in sweet fruits, especially in grapes. 20 to 30% or in honey. Glucose is essential constituents of human blood, and the blood normally contains 65 to 110 milligrams of glucose per 100 ml. Essential constituents of human blood. That contains 65 to 110 milligram of glucose per 100 ml blood. In diabetic person, the glucose level may be much higher. The preparation of glucose is from sucrose and from starch. Sucrose is derived from sugarcane or cane sugar. Or starch is mainly derived from maize or potatoes or sweet potatoes. Let's see the preparation of glucose from sucrose. Sucrose C12H22O11 C12H22O11 boils with dilute HCl or sulfuric acid. Glucose and fructose is obtained. 1 mole of glucose and the 1 mole of fructose is obtained. So sucrose is disaccharide, while it hydrolyzes into two different molecules, glucose and fructose, and this is the main product, the glucose. And the second preparation is from starch. Starch mainly derived from maize, potatoes or sweet potatoes. C6H10O5 is the general structure of starch or cellulose, which on hydrolysis in presence of acid boils at 393 Kelvin temperature and 2 to 3 atmospheric pressure. Glucose is obtained. Here now let's see about the structure of glucose. Or dextrose is aldohexose and its molecular formula is C6 at 12 6. Its general structure is CHO CHOH 4 times CH2OH. This structure is discussed under the following heads. Number 1 is open chain in formula. Here A. The B, its configuration. C, its cyclic structure. And D is Haworth representation. First of all, let's see open chain in formula. Its molecular formula is C6H12O6. Number 2, the presence of 6 carbon, presence of 6 carbon. Here the 6 carbon presence in a straight chain. Glucose on heating with HI, it gives hexane is the straight chain. The normal hexane is obtained. Glucose on heating with HI, hydroiodic acid, that gives normal hexane or straight carbon chain. So this proves that there is presence of 6 carbon straight chain. Number 3, presence of carbonyl group. CHO CHOH 4 times CH2OH glucose on react with hydroxyl amine, oxime is obtained. Here CH double bond and OH. Rest of the part remains as it is. This glucose enzyme, and hydrogen cyanide molecule is added to glucose. This glucose cyanohydrin. This will be confirmed that there is presence of carbonyl group, that confirm presence of carbonyl group. The glucose will react with hydroxyl amine, that gives oxime, and the glucose react with hydrogen cyanide, that gives cyanohydrate, that confirms the presence of carbonyl group in glucose. Now the next is there is presence of aldehyde group, is most important for 2 marks, and this is also important for 2 marks. Glucose on react with glucose CH2OH. The oxidizing agent like bromine water, it will be oxidized and it is converted to gluconic acid COOH. So aldehyde will be converted to carboxylic group. It is named as gluconic acid. That will be confirmed there is presence of aldehyde group. Bromine water is weak oxidizing agent that oxidize the aldehyde group and it is converted to carboxylic group. Gluconic acid, glucose to gluconic acid. Number 5, there is presence of 5OH group. Presence of 5OH group. Here in the structure 4 and fifth OH group is present. How will you prove there is presence of 5OH group? Glucose on react with acetic anhydride, CH3 CO CH3 acetic anhydride, that gives glucose pentaacetate. Here CH will be remain same and this part will be attached and the O CO CH3 4 times and here CH2O COCH3. Okay, so it is named as glucose pentaacetate. So 5OH group should be attached to the different carbon atom, or shall be attached with 5 different carbon atom. That will be confirmed that there is presence of 5OH group, or in another word, acetylation of glucose. On acetylation of glucose, glucose pentaacetate is formed. And the last is there is presence of primary alcohol CH2OH, primary alcohol. Here in glucose structure, CH2OH is 6 with 6 carbon is primary alcohol. Glucose on react with strong oxidizing agent like nitric acid, aldehyde is converted to carboxylic acid, CHOH will remains as it is, and this primary OH group will be converted to carboxylic acid group, and it is named as saccharic acid, or another name is glucaric acid. While glucose on oxidize with mild oxidizing agent like bromine water, mild or weak oxidizing agent, it is converted to gluconic acid. And this gluconic acid is further oxidized in presence of concentrated nitric acid. It is converted to saccharic acid or glucaric acid. See, this is the difference between true structure of gluconic acid and glucaric acid. Here in glucaric acid or saccharic acid, there are two carboxylic group, while in gluconic acid only one carboxylic acid group. So on oxidation of glucose, saccharic acid is formed that confirms, or that indicates there is presence of primary alcoholic CH2OH group is present. Okay friends, so this is the first part of the structure of glucose structure. Next time we will discuss its configuration, cyclic structure and Haworth representation. Thank you very much.